So today's program is the first in a series of 3 programs featuring Themed Entertainment Association Masters of Their Craft, which recognizes exceptional individuals who have made a lasting impact in the themed entertainment industry, shaping experiences that delight and inspire worldwide. And I am so excited to introduce our special guest today, Frank Wigand. Frank has a broad range of experiences involving anything that moves, from record-breaking fast trains to space travel simulators. He started his theme park career at Walt Disney Imagineering, where he led the mechanical engineering efforts on pioneering attractions like the Indiana Jones ride, Epic Theater Stunt Show, Splash Mountain, and Star Tours. Frank founded the TWT Group, an engineering consultancy in 2000, where he designs and manages the development of complex equipment used in museums, science centers, and theme parks around the world. Frank has been named a TEA Master for his work in ride systems and mechanical engineering. So thank you so much for being here today, Frank.
Oh, my pleasure. Thank you, Christy and Vicky, for your hospitality and for the opportunity to have this. So I'm really excited to be here, and hope I can enlighten some folks and get them excited about themed entertainment.
We're ready for it. We're excited. Thank you so much. Before you begin, I just want to remind everyone, if you have questions, please place them in the chat and we'll make sure to share them with Frank at the end. Thank you. Go ahead, Frank.
Okay. So I thought I'd start with a couple general career lessons. These are sort of things that I wish people had taught me when I was starting out. Modified quite a bit because of the difference in time, and especially over the last year or so because of AI. And I don't know how it's going to affect us all, but I know it's going to affect us significantly. And I tried to put things down here that I think are reasonably AI tolerant. So one is to know the fundamentals. So in the case of what I do, which is sort of machinery design, it's things like, physics, calculus, advanced math, how materials behave, some thermodynamics, things like that. Whereas if you're, say, in electrical engineering, it would be more about, motors and capacitors, resistors, think how those things work, how computer chips work, how sensors work, things of that nature. And when I say know it, I mean like know it well enough to teach it. Because, knowing the fundamentals, you'll be able to solve problems a lot easier. Second thing is be outstanding. And I put outstanding in apostrophes or quotes there because I didn't mean it the way it's normally envisioned. What I mean by that is think about, say you're applying for a job or applying to college, and the person reviewing your application or resume has maybe 100 of those sitting on their desk or in their file. And their job is going to be to take that 100 and narrow it down to maybe 3. So you want to have something there in your story, however you're telling your story, that makes that person want to talk to you some more and not, do delete, because they have to delete most of them, right? So that might be something to do with the job. So maybe if you're applying for an engineering position, maybe you were the leader of your robotics group at school, and you won a competition. That would be really important. That would be good. Or it might be something completely different because maybe you're applying for an engineering job and you're a concert pianist, or you got your pilot's license when you were 16, or you spend your summers teaching English to kids in Bolivia. That would make the hiring person or the admissions officer think, I'd like to know more about that person. So if you can cultivate something like that, I think that will help you out. Number 3 is work on your interpersonal skills. I just read an article by Mark Cuban, who you probably know from Shark Tank. And he was saying that interpersonal skills are going to be super important in the future because uh, with AI and all the other technology, we don't spend very much time talking to one another face to face. And if you can do that, if you're good at it, that gives you a competitive advantage over other people who may be competing with you. The fourth thing is to view jobs or your job and your schooling as an investment. So what I mean by that is, let's say I wanted to be a professional tennis player. Say I was, 12 years old, wanted to be a professional tennis player. What I'd do is I'd go out and I'd hire a coach, I'd hire a nutritionist, I'd probably hire somebody to take care of my muscles for me. I'd hire a whole bunch of a team of people and I'd pay them. And what are they going to do? They're going to make me do stuff I don't want to do. They're going to make me hurt. They're going to, cause me not to sleep. They're going to tell me to eat stuff I don't want to eat. And I'm going to pay them to do that. And the reason I do that is because they're teaching me skills that ultimately people will pay me because I've got those skills. So, try to think of, the drudgery or the teacher made me write another paper or I got a test I have to study for. Think of that as developing skills that ultimately, when you go out into the working world, uh, people will pay you because you have those skills. And then finally, ethics count. So you don't want to uh, get caught stealing, cheating on a test, anything like that, because it's kind of surprising how long something like that will follow you. So, ultimately, all you have to uh, sell is yourself and your integrity. And a school or a company isn't going to want somebody representing them that they can't trust. And once you lose that trust, uh, it's very difficult to get it back. So the good news is that's the only word chart I got. So the rest of them are all pictures. So we'll talk a little bit about what engineers in general do, and then we'll focus more on theme park uh, opportunities. So the top line, there's three pictures there. That's what most people think of when you say engineer. People with, poor fashion sense and, math and maybe Scotty worrying about his dilithium crystals. Um, the bottom is more like what it really is. We work with computers, we work with technology, and we spend a lot of time out in the field. And that middle picture is just a guy I used to work for, and so I put his picture in there. So one thing that engineers do is come up with ideas and concepts. So the upper left picture is a vehicle that we designed. This was for Disney, but it's not fully designed. It's, we do it in a CAD system, computer aided design system. And it's kind of good enough to show you about how big it is. And, we get roughly the size of the motors and stuff like that, but it's not ready to build. And then if they like it, then they say, okay, they give us, tell us to take it further. Um, or they may not. Below that is a project where there's a mechanism that went perfectly one way, but it wouldn't work in reverse. And so, okay, well, we need to redesign it. So we sketched up um, another way to do it that would go in reverse, and then turned that into the computer-aided design model, which is what we've ultimately built. And then that flow chart on the right is what we call a hazard analysis. So, especially in theme parks where, you know, if something goes wrong, somebody's probably going to get hurt. And nobody goes to Disneyland or Universal or Six Flags thinking they're going to get hurt. So we work really, really hard to make things super reliable and super safe. So that flow chart there shows one thing that could go wrong where the vehicle goes too fast. Okay, so we think about all the ways the vehicle could go too fast, and make sure that we have features in the design that prevent that from happening. And or if it does happen, we bring the vehicle to a safe stop without hurting anybody. And oftentimes that requires adding a lot of stuff to the vehicle that nobody thought of before we did the hazard analysis. So the sooner we can implement that in the design rather than later, the better off we are. So after you do the initial concept work, then you have to do a bunch of analysis. And this is the stuff that's very math heavy. So the graph on the left, you could probably tell is a roller coaster where every hill is a little bit lower than the one before it. And the reason for that is you're always losing energy because of air resistance and drag in the wheels. And you have to really accurately figure what that's going to be because you don't want the coaster to not make it up the next hill. That causes a bad day. So there's a lot of math that goes into calculating, the track and the height and all that sort of stuff. And then the the thing on the right is if any of you are seniors, maybe you've done some matrix algebra, but we still use that, and there is a reason to study it. This was for a little machine that went around in a circle, but it wasn't centered, and we had to calculate the forces as it goes around, so we knew how big of a motor we needed to drive it around. And then the thing at the bottom is a computer model of a structure, which I'll show you a little later. And this is called finite element analysis. So we model the geometry and the materials, and then we tell the model where the forces are that are on that part. And then the computer calculates the stress in every little spot throughout the part. And the parts with the little spots with the highest stresses are red. And so we have to go look at those and see if um, the stresses are too high for that material. And if they are, we gotta change the design somehow. So those are some of the analysis type things that we do in theme parks. And then once we kind of have the concept, got the analysis, modified the concept to comply with the analysis, then we have to detail it. So this the thing on the left is that's a kind of a magic gag that is in Tokyo Disneyland, where the fit you got this big fish and then poof, it turns into a little fish. But in that model, it's a lot more detailed. So every little nut, bolt, and washer is in there, and every piece of structure and every weld and every little piece is in there so that we can give that to a manufacturer and they can just build it. It's everything you need to build it. Now, sometimes we don't do that. Sometimes we write a specification. So that's what's on the upper right. So that is, that was for a roller coaster and it was about 200 pages long. So it talked about everything that coaster had to do. And then that information got sent out to companies that make roller coasters, and then they provided a proposal and a cost, and then to decide who's going to get it after get back up after fainting at the cost. And then all these projects have a schedule associated with them. So that's what's on the lower right. So it's all these tasks that you need to do, how long they're going to take, and which ones have to be done first, and then the next one, and then the next one. And then you'll see that some of them are red, and those are the ones that have to be done on time, or you don't finish on time. So it's stuff like, if you were going to go do the laundry. Well, okay, step one is, okay, I got to pick up all my clothes and throw them in the laundry basket. Then I got to take the laundry basket to the washing machine. Then I have to sort it all out and so on and so forth. So it's like that, only some of these are, a thousand tasks that are all interrelated. So then once that's done, then we start to build stuff. So this is some pictures of fabrication and testing. So the thing on the upper left is a machine I built to test a joystick. So there's a ride called Mission Space in Epcot Center or Disney Park in Florida, and everybody in the ride has this joystick, and the joystick actually fights back against you. You're trying to land this spaceship, and we knew that if we just bought a joystick, at Best Buy, it wouldn't last an hour. So we built one up, and then what this machine does is just beat it up day and night. And then we beat it up until it broke, and then we figured out why it broke, and then we made it stronger and did it again. And eventually we got it so it was strong enough that it would last a couple of years in the attraction. And then the upper right picture is a seat that we did for the space ride at the Kennedy Space Center. And this ride is a simulation of being launched in the space shuttle. And so you see that the seat we got there is it's tilted way back because if you were in the space shuttle, you'd launch with your back horizontal. And so we built the seat up out of wood and plastic and stuff to get the dimensions of it right and make sure it felt right, make sure you could get in and out of it and stuff. So we started there and got the dimensions right. And then you'll see the real one on the next page. And then below that is a test that we ran on a ride called the High Roller. It's in Las Vegas. It's the largest operating Ferris wheel in the world. And what we were testing there is to make sure that in a wet day, the tires that move the Ferris wheel around wouldn't slip and cause the whole wheel to, move the wrong way or go too fast. So yeah, the guy there is shooting water on the tires that push the Ferris wheel around and making sure that it doesn't slip. So then after all that, if you get the testing and fabrication done, then you install it. And then maybe after it's installed, there's some maintenance that needs to be done or repair work. So the upper left is a ride that's on a cruise ship, biggest cruise ship in the world at the time. And it's a 120-foot long boom crane with a bubble full of people, maybe 12 people on the end of it. And it goes up above the ship and off to the side and all that. So the people in it get a really good view of either harbor when they're coming in or they can see maybe 100 miles out into the ocean. The picture to the right there, the steel piece, that's the piece that I showed earlier with the finite element analysis, and you can kind of see that it got messed up. So we had to figure out a way to fix that without having to start all over on the part. It got overheated, is what happened. Down below in the middle, you'll see those seats. So those are the real seats that went into the attraction, and they're being installed into the simulator. You can kind of see in the background there, the 2 rows are already in, and then there's 3 rows left to go. And then the bottom right that was a roller coaster wheel. It didn't work out very well. But it was on a test facility, and we were just testing to see how fast we could run it, and it got over 100 miles an hour, which was pretty good. But we didn't want it to fail that way, so we had to kind of redesign it. Okay, so those are sort of the general things that engineers do, and I'll go over some projects that I've been involved in. So the first one, I think Christy said was Indiana Jones. So uh, I was one of the first people on that job, the first of three of us. And at the time, this was in the mid 80s, and simulators were just starting to be a thing. And we thought, well, geez, what if we put one of those on a ride vehicle and rode it around? Would that be fun? And so we built one up and kind of a mock-up and that would operate, and we drive it around and we figured out cool stuff we could do with it, and some of the stuff we tried didn't work and some of it did, and then we would show this to the creative people and say, well, what do you think? And they say, oh, hey, that's great, but can you make it do this? And I say, well, okay, see if we could make it do that, and then some of the things worked out and some of them didn't. And then eventually we had this opportunity to do an Indiana Jones ride, and it was the perfect vehicle for that. So we, you know, customized it to be just for that ride, and it worked out really well. It's one of my favorites. Hopefully, many of you have ridden it too and enjoyed it. This one is from Universal. So this is the original Jurassic Park ride. And what was going on there is the boat goes down an 85-foot drop. So it's going about 60 miles an hour when it hits the water. And what we were finding was that the water level would fluctuate. So sometimes it would be a little high, sometimes it'd be a little low. And if the water was high and there weren't too many people in the boat, it would stop too fast. And similarly, if the water was low and it was the USC football team in the boat, then it wouldn't stop fast enough and it would go too quickly into the next turn. So um, rather than try and rely on the water, we put these electromagnetic brakes in, or actually magnetic brakes in, and raise the track up a little bit. So you get a little bit of splash, but not a whole lot, and the stopping is a lot more consistent. Staying with the Jurassic Park theme, when the ride opened, and this was like in 1997, I think, um, the dinosaurs all broke like right away. So we had this crash program to take a dinosaur out one at a time, tear it all down, figure out all the stuff that was wrong with it, figure out how to fix it quickly, and then get it back running again. And there was all kinds of stuff uh, that was wrong. Some of it was structural, some of it was bad bearings, some of it was the hydraulic actuators that moved the figures. Some of it was the skin, some of it was the wiring. And so, yeah, we spent about a year taking one of them out, figuring out what was wrong, fixing it, and putting it back in. So, but it was a lot of fun. Um, this is another Universal ride. This is the Mummy ride, and it's a big vehicle you see there, and it's got this pivot in it. So the front two rows of seats pivot relative to the back two rows, and we had to do that because we had to put this a roller coaster, and we had to put it in a building that wasn't made for a roller coaster. It was much too small. So in order to get it to go around the tight turns, we had to put this pivot in it. But you can imagine that if that pivot failed, if the little shaft failed, it's like a hinge, you'd have a really bad day. So we had to figure out a way to uh, tolerate a failure, even though it's just a pin really that goes through there. So we actually did. We figured out a way to tolerate a failure of the pin. So we had a secondary uh, path for the forces to go through. And that secondary path could last a day. And the other important thing was that it had to be easily inspectable to see if the primary structure had failed. So the maintenance guys can check within about 20 seconds that the primary load path or hinge is okay. Um, so I got a patent on that actually. And then the upper right picture is a friend of mine, uh, and he's an engineer. He's paralyzed. He's paralyzed from the waist down, and he helps us when we do these rides to make them accessible for as many people as possible. So he's practicing getting into the seat for the mummy and telling us, well, can you put something here and put a hand grab there and stuff like that? And we did. And so it helps people, with a certain level of disabilities to still ride. And it's always fun working with him. His name is Peter Axelson. This is more of a showpiece, so maybe some of you have seen Hoberman spheres, a little toy, a little plastic toy. The fellow in the middle there is holding one. And the one that we built is the biggest one in the world. And when it's all the way open, like it is in the lower right, you could put an SUV inside of it. And this went in a 6-story atrium in a shopping mall in Otaro, Japan. And of course, the thing we had to worry about is it had to look like it was floating in the middle of the space there. But we also had to make sure that it couldn't possibly fall down. But we had to be able to get it to go down so they could clean it and maintain it. So it was pretty tricky to make it look like it was suspended in air and and still be able to be safe and be maintainable. So we also, would shoot lights, robotic lights at it. And so when it would dance to the music and the lights would go off, and it was a very cool show. Um, this is a little bit different. This is the Museum of Science and Industry in Chicago. There's a exhibit there in one wing called Science Storms. And this was also a lot of fun. We got to work with some Nobel Prize winners on this, to helping design these exhibits. So the upper left is a Tesla coil, so that's simulating lightning. And that's pretty impressive. It's very loud, but it's lightning, it's real lightning. The picture to the right top, that's a wave tank. So you design, there's a little like an iPad, you design a wave, and then the wave tank makes that wave, and then the wave travels along this 30-foot tank and then crashes. You can see it crashing on a simulated shoreline, and you can see the damage that it does. And then you can do a different kind of a wave and see what happens. The picture in the middle, that's a picture. That's not a rendering. That's the real thing. The thing in the middle there that looks like smoke, that's a 60-foot tall tornado that you get to uh, drive. So you can make it big and nasty, or you can make it real skinny like a thread, and but you get to play with it. And the orange thing is a rotating avalanche, and you get to play with that too, and make this avalanche and go around. The thing on the lower left is an exhibit that has fire, water, and lasers in it. And you get to manipulate all three of those by yourself. There's no docent or anybody. You get to do it yourself. And it shows you how a sprinkler that could be in say, in a roof or a ceiling, is able to quench fire. Um, and then the lower right is a picture of my grandson playing tic-tac-toe with a robot. Sticking with the museum theme, this is the California Science Center, which is down near USC, near downtown. And the California Science Center was awarded the Endeavor, one of the real shuttles. And you might have seen it. It's been on display for a couple of years in a horizontal position. And now, if you go by there, you'll see the new building, and it's installed vertically with the external tank and the solid rocket boosters there. So it's the only one that's in its launch configuration. And uh, I helped with the exhibits, and I helped with moving it from when it came in to Los Angeles Airport. We had to get it to the Science Center, so I helped get it there. And so I took this picture of it getting stuck in the LA traffic at a red light. So. And then the lower picture is a exhibit that I came up with for essentially it's putting somebody in a wind tunnel flying. So you can manipulate the angle of the wing there, and if you do it right, you actually go up and down. So that's an exhibit that will probably be in the Science Center when it opens, probably in about a year and a half, I think. We're building stuff for that now. This is that earlier I showed you a picture of test on the Ferris wheel, and this is the real Ferris wheel. It's in Las Vegas, and each to give you an idea, it's 550 feet tall, and each of those little bubble things there holds 40 people, and it's about the size of a two-car garage. So the thing is really, really big. And so we were involved in basically integrating all the different pieces of that and making it work and proving to the Clark County, who was the authority that we had to show that was going to be safe we had to do all that and work with the other interesting thing there was working with the heavy rescue team uh, there at Clark County on how to rescue people if the thing stopped and we couldn't keep it going. So in the upper right picture, you see kind of a ladder going around the vehicle, and that's for rescue. The firemen actually climb that ladder, and there's a hatch on the top, and they can get the people out. So that was a fun project too. Going back to Disney, this is the Millennium Falcon. Maybe some of you have seen that at Galaxy's Edge in Disney or DCA. There's a similar one in Walt Disney World in Florida. And the interesting thing here was it was uh, contracted to a company in China, and they had never done a big job like that for Disney, and they were worried about, what it would, whether they could do it or not. So they hired a couple of us to help them through the process, and we had to build the whole thing complete in China. The Disney people came off and accepted it, and then actually both of them, and then we had to take it down, take it all apart, and put it in sea containers and ship it across the ocean, one to California, one to Florida, and then put it all back together again. And you can just tell by the look of it, it doesn't want to be in sea containers. It's big and it's round, and it was very difficult to get it in the sea containers. But we did it, and it came out great, and everybody was happy with it, and the company made money. And that's a picture of my granddaughter when it first opened. Let's see, how are we doing for questions and time, Christy?
Yeah, we're doing good on time. I'm enjoying all of the stories about all of your experiences. I'll mention to everyone if you have questions, please put them in the chat. We did have a question related to just the variety of experiences that you've shared so far. I know you have some more to share as well. But just how did you decide to for your engineering career to go into themed entertainment to make these kinds of things?
Oh, I didn't. Uh, so what I really wanted to do is this kind of stuff, actually. You're one slide ahead of me. So I wanted to do high-speed ground transportation. And I wanted to do that because I always liked going fast. I got the speed gene. And I thought, well, how can I do that but do it in a way that's helpful to people and good for the environment? And I thought, well, if I could do, mass transit, that would be pretty cool. And it would be good for people, especially people that, need to get to work but can't afford a car, no pollution or very little. And I would like to do that. So I actually started out, I got a job doing that. This is actually called the Linear Induction Motor Research Vehicle, and it set the world speed record for uh, trains. So it's on a regular train rail, railroad rail, but it was super precision. And we got that. It's about the size of a locomotive, weighs about 50,000 pounds. And it went from 0 to 250 miles an hour and back to 0 in 6 miles. Um, I got to be co-pilot for a while. The pilots were all test pilots from Grumman, so they're used to flying planes as test pilots, and it was amazing. Riding that thing was amazing and very scary because nobody had done it before. Those engines on the back are actually surplus missile engines that we got from the Army for free. And that helped us get up to speed quicker. And yeah, so the picture up there, I was putting some of the rail in at the time. So that's what I wanted to do. And I did that for about 5 years, and then there wasn't any money or projects left for that kind of work. And so I thought, well, okay, what else can I do? And I tried to get a job in medical products because I thought, well, that's good for people and it's engineered and stuff like that. But people looked at what I did and said, well, that's nothing like the little tiny needly things or little tiny electrical things that we do. So I couldn't get a job doing that. So I got a job working in aerospace, working on the F-16, which is a fighter plane, but they have it's one engine, and if the engine fails, the plane doesn't fly on purpose. It's unstable on purpose to be maneuverable. But they have this thing in there, this rocket fuel powered turbine that gives the pilot enough control that he can land it if he has an engine problem. So I thought, okay, well that's good. I can do that. So I did that for a while. Um, and then when that was in the early 80s. And then um, I kind of got tired of that and I could see there wasn't going to be a lot more work in that area. So I literally answered an ad in the newspaper for a company called WED, which I had no idea what it was, but they wanted some of the stuff that I had done. They wanted simulator experience. That's what I did my thesis on. They wanted hydraulics. I'd done a lot of hydraulics. They wanted vehicle design. I'd done a lot of that. Um, and so I thought, well, this would be a perfect job for me. So I applied and got an interview. And I realized it was Disney. And oh, okay. And, and it took me 6 months of pestering them before they hired me, but that's how I got into it. So, yeah.
So even further back, when did you first realize you wanted to be an engineer? Was there some interest from your youth that contributed to that?
Yeah. I always I don't know if anyone even does this anymore, but I was into model trains when I was a kid, and I had all these, what I would do because my folks didn't have a lot of money. I would wait until after Christmas, and all the stores would have these kind of broken or open box trains and things like that, and I would buy them because I could get them for like 20%, and then I'd fix them. And I enjoyed doing that. And then I, add to it, add to it, add to it. And I thought, okay, well, I'm pretty good at this, I guess. And um, so I thought, and I really liked, making the trains go faster and all that kind of stuff. And then I got into go-karting and stuff like that. And then I got my driver's license, and I wanted to go fast all the time. So that's kind of how I kind of got into it.
Well, sort of speaking of that, we do have a question talking about there's so many different types of engineering. So what
Mhm.
kind of engineering is needed to study to if you want to sort of build rides?
Okay. Yeah, so uh you probably noticed that everything I mentioned is completely different than every other thing I mentioned, which is why I say, know the fundamentals. Because that you always start there. Um, there's a lot of different kinds of engineers. The main ones are electrical engineers, so the power type engineers, so motors and generators, that kind of stuff. And then the control system engineers, which is the computers that control the rides and the shows. So there's a lot of that. Um, and then there's mechanical, which do the kind of things that I've shown here, the structures, the mechanisms, the wheels, all that kind of moving stuff. Those are the main types I'll say for the rides. Now, of course, there's also show equipment, which uses sort of the same group of people, but there's some more people that do like rigging and things like that. And then, of course, there's the facilities. The facilities, the buildings are all super custom and have to be integrated tightly with the ride, right? If you think of something like Pirates of the Caribbean or the Star Wars rides, they're built into these, or even Big Thunder, they're built into these crazy buildings, and so that's facility design, uh, HVAC, so utilities, um, structure. Uh, Earthquake, all those sorts of things that, architecture, a lot of architects involved, a lot of project managers too. So a lot of the engineers become project managers.
We
And
have
then
a
of course there's
question. Oh,
people that write the
sorry.
software too, I should say too, control
There's
engineers. Right.
so many avenues.
Yeah, no, there's
Yes.
kind of, very there's a lot of different kinds. And a lot of the people that have worked for me actually have a physics background. They got their degree in physics.
Well, that's a related question. Do you know of any jobs or careers that are engineering related for people without a college degree? Are there opportunities
Oh
there?
yeah, yeah, yeah. Actually, I was running tests today on a wind energy project, and the two guys that I was working for, neither of them has a degree. One was the controls engineer, and the other was the mechanical engineer on it. And they become engineers just because of experience, but neither of them has a college degree. I think both of them, I think, have an associate degree or some college, but not a 4 year, bachelor's degree. And actually, the engineering technology. I was talking to actually a Disney engineer earlier this week, and she was telling me that uh, there's a huge demand in industry for engineering technology people. So people that understand some of the things I've talked about but not in like the super theoretical depth, but are, generally also good with their hands, and can build stuff.
Awesome. That's great to know that there's those opportunities.
Oh
And what kind
yeah, no, there's a lot of opportunities for that sort of thing. Yeah.
is there any kind of education or internship programs or something like that that you would recommend for someone who's specifically interested in the themed entertainment industry?
Yeah. Um, well, I can tell you that both Disney and Universal hire a lot of interns. But what I've heard, and again, I'm not there anymore full time, but um, they're actually hiring degreed engineers as interns now. That hasn't been the case always, but I think a lot of companies are reluctant to hire at the moment full time. But there are internships at Disney and at Universal. And some of the smaller companies, will often hire an intern or two, excuse me, and oftentimes those internships, they don't have the glitz, but you learn more. No, because they make you do a whole bunch more stuff, what I would suggest for somebody who's interested in that is get involved in TEA because there's what they call a next gen program, which is specifically for younger people who want to get into the business. They have networking opportunities and other educational opportunities for them to get exposure to some of the companies, or they have tours of some of the companies, open houses, things like that.
I'm just going to mention again that TEA is the Themed Entertainment Association,
Oh,
which
thank
Frank
you. Yes.
Frank is a one of part of the masters of their craft program through TEA. So I am going to put the link in the chat to the next gen program that Frank just mentioned, so that you can find out more about that. So thank you so much for mentioning that. I had that link ready to go.
Okay.
And we have a question about you mentioned sort of different having different opportunities at different tasks and those kinds of internships.
Hmm.
So what is kind of a typical day look like for you or for an engineer in your role? Do you have a typical day?
No, no.
No.
There are some days I put on a tie. Well, I don't put on a tie anymore, but almost. And sit in the design review and ask questions and say no, you forgot this and stuff like that. That's some days I do that. Today I got up, I went to a shop, and like I said, I was running tests on this wind energy device. Hundreds of horsepower floating around. We're trying to get this test facility up and running, and I was literally swinging wrenches, and then I had to come back for this. Uh, and then other days I sit at the computer and design stuff, or other days I'm in meetings, trying to figure things out, or writing proposals, or things like that, or recruiting people. So and I'm kind of a generalist. I'm not very good at anything, but I'm a little bit good at everything. And so, but there are some engineers that, when I was talking about analysis and things like that, that's kind of all they do. And they're really good at it and they like doing it. And their days are a lot more predictable than, somebody like me.
I love that. We do have a question, which is what do you have a favorite project that you've worked on?
Well, yeah. Um, the one on the screen is one of my favorites. I was like 24 years old when I did that, and you know, uh, and they gave me the job because nobody else thought it would ever work, and I was too young and naive to think about that, so I took it and we got it to work. That's one. The Indiana Jones ride is another one. Another one is the Indiana Jones show, which is in Florida, and that's a stunt show. Disney had never done a stunt show before, and normally a stunt show of that uh, complexity would take like 3 or 4 years, and we did it from when they gave us the storyboards to when we were showing it to the public in 9 months. And well, I guess I got time to tell the story. So what happened was we were showing it to the public for the first time. I didn't think we were ready, and I argued, no, we're not ready. We're not ready. I said, nope, too bad. We're doing it. And so, okay, so the people come in and we're running the show, and it's 3 scenes from Raiders of the Lost Ark. And so we do the one scene, which is with the rolling ball and all that. And it's this huge set. And the set, we have to get the set off this stage. And then the second set is when Indy and Marion are in Cairo and they get in, Marion gets kidnapped and taken by the bad guys. And then Indy rescues her, and there's all this stunts that go on with that. And then that goes off stage. And the third scene is the flying wing, where the Nazi flying wing comes on stage, and the pilot gets out, and then Indy tries to steal it, and this great big German mechanic fights him, and then the German mechanic gets chewed up in the propeller, and the whole thing blows up, and there's fire and machine guns everywhere. And so there's a lot of stuff going on. And so I'm running around backstage the whole time and sweating bullets and what about this? What about this? And hurry up and where's you're not on cue and all that stuff. And then at the end, I heard this kind of noise, and it was like, and I thought that we had ruptured like an airline or something. And I thought, oh no, or worse, a gas line for the flame. And so I'm running back to where the tanks are to see if there's a leak. And then I realized that roar was the audience, and and they loved it. So uh, that was pretty cool. So that was, that's the kind of stuff that kind of keeps me going on things like this. When there's a bad day, I remember things like that. And that's another good thing about working in the theme park uh, uh, world, that if you're having a bad day, you can go down to Universal or Disney or Six Flags or Knott's Berry Farm and just sit there and watch the people, and see how much fun they're having and think, okay, these people waited an hour in the hot sun to go on a 5-minute ride after paying $100, and they came off and they couldn't be happier. You know, that's pretty cool. That's pretty cool.
Well, I'm
So,
also going to give you a review from the chat earlier when you were sharing some of the projects you worked on that said these are literally my favorite rides. So that
oh,
is from
okay.
someone in the chat. So you should also feel honored that
Oh, good. Well,
that
well, I'm
people are
glad
out
you
there.
enjoy them. I hope that's true for everybody there.
Thank you so much. Let's see. In terms of our other questions, did you have? We have a few more minutes left, so if we
Okay.
have a couple of questions, but if you had something else that you wanted to make sure that you get to before the end.
Okay. Well, I got one sort of encore when this isn't really themed entertainment, but this was pretty cool. So this is a house mover. And we designed this from scratch and got it built. And it picks up houses and plops. So the idea is they build the houses, say it's a subdivision. They build the houses in a big building, and then we pick up the house and take it to the lot that it goes to. And these are big houses. And plop it down. It has to be exactly perfectly right. And then the vehicle has to uh, break into two and sneak out between the house that we just dropped and the house next to it and come back and get another one at 10 miles an hour. So that was pretty cool. And I was the driver for that too. So that was pretty cool. And that uses all these different capabilities. It's got hydraulics and mechanisms and motors and controls, and the two sides of the vehicle aren't mechanically linked, so they have to stay in perfect unison or you crack the house, which would be a big problem, right? So that was pretty cool. That was pretty cool. Okay, all these questions?
No, I'm just imagining you, Frank. I don't know you very well, but I'm
Yeah.
just imagining you running around solving problems and fixing things all the time. Just trying to figure out a way. I love
That's what engineers do. We try and fix stuff, so
it.
or make things better is the other half of it.
Yes, and I know you talked a lot about sort of the testing and redesign process today, which I also think is pretty inspiring as well. That it is a process that just keeps going and is always looking for improvements.
Hmm. Yep. Yep.
Um, Great. Well, I had one question that I brought today that I wanted to make sure we get to before the end of the program, since this
Mhm.
is a library program. Do you have any favorite books or books that have inspired you on your journey um, there?
Okay, well, I guess some of my favorites are the Universe in a Single Atom by the Dalai Lama, or anything actually that the Dalai Lama has written. Um, One book that isn't really related to what I do for a living that had kind of a big effect on me is 10% Human, and it's about the microbiome. So all the viruses and bacteria that's in your gut that allows you to digest food and 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 your body to keep working. And I always kind of, wondered about that because they don't really teach much about that in school. And I thought, well, that seems like it's really hard. And, and how does that even work? So this book, 10% Human, was talked about that. And of course, since then, there's been a lot of research in that. You probably hear about the microbiome. But, you know, I'll say 5, 10 years ago, nobody knew what that meant. So that was one. And then I brought one here too for anybody that may be interested in what I presented. And let's see, it's not. Okay, what it's called is 21 Things Every Future Engineer Should Know. And it's by Pat Remick and Frank Cook. Not the most exciting read, but if you're interested in the kind of stuff that I talked about today, it's worth picking up. So 21 things every future engineer should know.
A recommendation from you is very valuable, I know, for our
Okay.
potential future engineers in our audience today. Um, so with that, I am going to end it unless you have any last words you'd like to share with us, Frank.
No, I just want to say thank you, and I would encourage everybody in the audience today to tune in next week for the next
Yes.
exciting episode where you'll get more of the artistic side. I specifically didn't talk too much about that, but one of the cool things about doing this kind of work is getting to work with artists. Most engineers don't get to do that and artists and Nobel Prize winners and astronauts and people like that. So that's been one of the coolest things about this job for me. So, but tune in next week and you'll hear from some other very interesting people and good friends of mine.
Well, perfect. Thank you for that lead in, Frank. That was wonderful. So yes, thank you so much, Frank, for being here. And as he mentioned, we'll be having some future programs related to that. Next week we have a program that is called Steam Powered Storytelling. It is more on the creative side of themed entertainment, as Frank mentioned. So I hope you join us with that. That was on August 20th at 4 p.m. I believe there was a link just placed in the chat as well. And then we are having a program called Designing Theme Park Attractions on August 27th also. So please join us for those. And again, thank you so much to Themed Entertainment Association for partnering with us on this program series. We hope that you'll be able to join us for one of those upcoming programs. You can visit the link in the chat, and you can also visit our website, lacountylibrary.org, for additional information. And thank you again to Edison International and the LA County Library Foundation for sponsoring these programs. And there's also a link in the chat to a survey to help us plan more STEAM programs at LA County Library. So we hope that you'll please answer that as well. And then check out our website for more information about upcoming programs, both virtually and in person, and follow us on social media for the latest updates. Stay safe and have a wonderful day. Thank you so much.
Bye bye.
Bye, everyone.